just as a reminder, the form that we know is ax squared plus bx plus c equals 0, right? But sometimes we have equations like this one, x to the 4th minus 13x squared plus 36 equals 0. And notice we have the equals 0 that matches on the right side. We have the constant c that matches. But we get to a problem when we get to x to the 4th and x squared, right? Because we do have an x squared term over here, right? We do have an x squared term over here, but it's in the wrong order. But then our bigger problem is we don't have that x. But what we can do is, what we can do is we can say, well, let's define a new variable, right? So this is like the substitution that we've done before with expressions. So I'm going to define the new variable to be u equals x squared. And the reason I'm doing that, is because I can rewrite the equation into this form right here, right? So we have u squared minus 13u plus 36, right? And the reason I did that is because obviously you can see that the x squared here turns into just u, right? Those are equivalent. And then the x to the 4th, that can be written as x squared squared, right? So x squared squared, which is just equal to, we can substitute in u. That,
and the S,
right? So we can do that. So after we do that, we substitute those two in here, right? So we have our u's now, right? So we have u's instead of x's, which is fine. And we can solve this by factoring, right? So we could use the quadratic formula if you wanted, but I think the easiest thing to do is factor. So notice that this factors into u minus 9, u minus 4, right? So u minus 9, u minus 4. And then that just means that either this part's equal to 0, either the first part's equal to 0, right? Or the second part's equal to 0. So either this part's equal to 0 or this part's equal to 0, right? So we set them both equal to 0. We solve for it, so we add 9 on both sides or we add 4 on both sides. So we get u is either equal to 9 or 4, right? And then after we know that, we can substitute back in because we know what u is equal to, right? It's equal to x squared. Since we know it's equal to x squared, we can substitute that back in. So now we get x squared is equal to 9 or x squared is equal to 4, right? And then the easiest thing that we can do to solve for that, right? If we have x squared is equal to 9, we can take the square root on both sides. So we get x is equal to, and whenever we put in our own square root, we have to take the positive or negative case, right? The positive or negative case of the square root, right? So the square root of 9 is 3. And then we do the same thing for the other one. We get x is equal to x squared is equal to 4. Take the square root on both sides. We get x is equal to plus or minus 2, right? So that's where we get our solutions to those, right? So if you want to, you can go back and check just to make sure that's correct, right? Because you'd have to substitute back in those 4 values to make sure that the original equation is true, right? So if you wanted to check your work, but I can tell you that all 4 of them are solutions to this. Okay, so what if we have something like this? So we have x minus 6x to the half power plus 8 is equal to 0, right? And notice here that we have something special, right? So we have this right here, right? But that's just equal to x, right? And then this one right here, we have x to the 1/2, right? Or just x to the square root. So what we want to do is we want to make the first term into something squared, right? So let's say u squared, right? And we want to make the second part, into, maybe. We want to make the second part into, maybe. Sorry, I'm having a little bit of difficulties with my pen. Okay, there we go. And we want to make the second part into minus 6u plus 8 equals 0, right? So we have it in this quadratic form. So the question is, what substitution can we use to make this work, right? So notice that u, right, when we have this u right here in the middle, we see that that is equal to 1/2, right? Or x to the 1/2, rather. See, it's equal to x to the 1/2. So my substitution here should be u is equal to x to the 1/2 power, right? Or if I square that on both sides, because I want my u squared, I can say u squared is equal to x, right? So that would make my substitutions correct for the quadratic. Okay. So now that I have that, now I can just solve this like a normal quadratic equation, right? And I think that this is another good one that we can factor. So does anybody know what this factors into? Right, so we have u and u. And that still equals 0. So does anybody know what does that factor into? So what are my two factors? So what multiplies to 8 and adds to a -6? So if we don't know, we can list off the factors, right? So the factors of 8 are 1 and 8, 2 and 4, and that's it, right? So neither of these is going to give us a -6, right? But we can take the negative of both of them. And I think that second one, if we take -2 and -4, that's a +8, right? And it adds to a -6. So it's u minus 2 and u minus 4, right? So solving for that, we either have the first one's equal to 0 or the second one's equal to 0. So we either get u equals 2 or u equals 4. Right? So then we do our back substitution. Remember, u is equal to x to the 1/2 power. Right? So I should have x to the 1/2 power is equal to 2, or x to the 1/2 power is equal to 4. Right? So after I do that, to solve for this, we square both sides, right? So we have to square the left, square the right. So if I square the left side, we just get x, right? If I square the right side, 2 squared is 4. Same thing on the other side, we get x is equal to 4 squared, which is 16, right? And I can tell you that if you want to check them again, like I said on the first one, you can feel free to. But I'm going to omit that in this lecture. So these are both true for sure. So, but if you plug them back in, you can check for yourself. So they're both true. So maybe I should say maybe they're both solutions. They're both solutions to the equation. So they're both solutions to the equation. Okay. Does anyone have any questions so far? Any questions so far? Okay. Oops. All right, so we'll move on here then. So this is another example where we're going to solve. Another example where we're going to solve here. So notice that we have the -2nd power and the -1st power. So we want u to equal x to the -1st, right? And the other thing that we want is maybe u squared. We want u squared to equal x to the -2nd, right? So that's what we want to do. And notice that if we have x to the -2nd power, x to the -2nd power this is fine, right? If we square both sides. So this is just maybe I'll write it out in one more step here. So if I want to square both sides, because we want u squared on this side, right? We get x to the -1st squared, right? And remember, when we're raising a power to another power, we multiply them. So we get -1 times 2, that's x to the -2nd, right? So just to be clear that we know that works. Okay, so now that we've done that, the next thing that we can do is substitute those in, right? So we get 20 u squared plus 9u plus 1 equals 0. And I think what I'm going to do here is, I think what I want to do is I think I'm going to use the quadratic formula on this one. So it's a little bit different, right? So notice that my A term is 20, my B term 9, and my C term is 1. So we'll plug that into the quadratic formula. So we get negative b, which is 9, plus or minus the square root of b squared, so 9 squared, minus 4 times a, which is 20, minus, or multiplied by c, which is 1, right? All over 2a, so 2 times 20. So what I notice here, right, and these are our roots for u, specifically u. So we get what? Negative 9 plus or minus, notice that 9 squared is 81, minus 80 is 1, so we get the square root of 1, or just 1, all over 40. So this is my u. And then I can change this into two different things, right? So we have u is equal to two different things. So the first one, u is equal to negative 8 over 40. That's if we add 1. And if we subtract 1, we get negative 10 over 40, right? Okay, so after we do that, notice that the first one simplifies to negative 1/5. We get u is equal to negative 1/5, or u is equal to what? Negative 1/4. Okay. And then remember that our u is x to the negative first power, right? U is x to the negative first power. So since I know that, I can substitute it, and I'll kind of move back up here just so I have a little bit more room. So we get x to the negative 1, or maybe I can write it as something like this. 1 over x is equal to negative 1 over 5, right? So that's just the inverse of x, right? It's just 1 over x. We get negative 1/5, or 1 over x is equal to negative 1 over 4, right? So it should be pretty obvious to see if you cross multiply, you get x is equal to negative 5, or x is equal to negative 4, right? So after we substitute those back in. Okay. So again, I'm not going to prove it, or not going to show it, but this is our solution set, right? So if I wanted to show that as a solution set, right, we can go x is a number such that x is equal to negative 5 or negative 4, right? So that's our set builder notation, right? So we're just saying that our solutions are negative 5 and negative 4. Okay, so we can do a similar thing on this next one. So this next one, notice how it's been grouped really nicely for us, right? We have something squared here, and we have just something here, right? And minus 6 equals 0. So we have this in sort of a quadratic equation. And the question is, how do we want to do our u substitution for this, right? How do we want to do the u substitution? So I'm going to say I'm going to let u equal to, right? It's just this middle term, x squared minus 4, right? And if I square both sides, I get u squared is equal to x squared minus 4 squared, right? So I can substitute those in. We get u squared plus u minus 6 equals 0, right? And notice that this factors really nicely. So this factors really nicely. So we get u equals 0. Notice that our two factors here would be what? A positive 3 and a negative 2, right? So that factors really nicely. So we get u is equal to negative 2, I'm sorry, a negative 3 rather, negative 3 or a positive 2, right? So I have to reset those equal to 0. And then remember that u is equal to x squared minus 4. So that's equal to either negative 3 or x squared minus 4 is equal to 2. right? So what we can do now is we can either, or what we can do now is solve these, right? So I'm going to add 4 on both sides. If I do that, we get x squared is equal to 1. Add 4 on the other one, we get x squared is equal to 6. Okay. And then we can take the square root on both sides, right? So x is equal to plus or minus 1, and x is equal to plus or minus the square root of 6. If we take the square root on both sides. Okay. Okay, so our solution set, maybe we'll write it a little bit differently this time. So our solution set is plus or minus 1 and plus or minus the square root of 6. Right, so that's our set of solutions. Okay, so those are our solutions for that one. Any questions so far? Are you still all right? Okay. All right, so that's the rest of chapter 8. Chapter 13 is going to be all about geometry and trigonometry. So this will be our last chapter for this semester. So 13.3, we're going to talk about the Pythagorean theorem. So what is the Pythagorean theorem? So the Pythagorean theorem, all it is, it just states that the sorry about that. So it just states, I think I wrote this wrong, but the square of the legs, right? So the square of the legs of a right triangle is equal to the square of the hypotenuse, right? So the hypotenuse is just the longest side. Hypotenuse. Okay. So if we want to state this visually, that the square of the legs of a right triangle is equal to the square of the hypotenuse, we can say, well, let A and B represent legs, so that's just going to be the 2 shorter sides, and let C be the longest side, right? So then what we can say is that this is a formula where we have the square of the first leg plus the square of the second leg is equal to the square of the hypotenuse, okay? And if I want to write that, or if I want to visualize that, right, we're going to do that with this picture. We're going to label the right triangle, and we're going to label the angles A, B, and C, and then label the last 2 sides B and C. Okay. And then the last thing we want to do is make sure that angle C is the right angle. Okay. So a right angle is going to be this one down here, where it's a 90-degree angle. We're going to label that C. Okay, so that's our right angle. And whenever we're labeling triangles, and we want to label all the angles and all the sides, the side that's across from the angle should be the same letter but in lowercase. Okay, so what I mean by this is we have C right here. So the side across from angle C is going to be letter C for our side. So it's going to be a lowercase c. Okay, and maybe I should write it maybe a little bit smaller, something like that. Right. So whenever we have a triangle, like if I have A over here, we can say that it's backwards as well, right? So since we have side A over here, we can say that this one over here is angle A. So it's the one across from it. It's the only angle that's not touching that side. So we're going to say this is angle A over here. And that just leaves angle B up top, right? And that means that the side on the bottom is lowercase b, okay? So your angle is always going to be across, so it's never going to be touching the side that it's representing, right? Or that it's paired with, okay? Okay, so a little bit more terminology here. Whenever we have, or notice that we have 2 angles, between 2 angles is a side, right? So between B and C, we have angle A, or we have side A rather, right? So notice that. So in geometry, we can label a side by the 2 angles that it's in between, okay? And more generally, we can actually just label it with 2 points, right? So if we want to just be this point capital B and point capital C, we can just label it like that as well. So as an example, we have side A. So side A here is just BC. So side A is the same thing as side BC. Okay. So what we want to do now is we want to rewrite this Pythagorean theorem up here, right? The Pythagorean theorem, and we want to rewrite that in terms of sides labeled BC or AC or AB, right? So we want to label them. So I'm going to finish out. I'm going to say that side B, that's represented by AC, right? Or CA. It doesn't matter. The order doesn't matter in this case. So I'm just going to say it's AC, and then C is represented by AB. Right? It's represented by AB. So if I want to make these substitutions, I'm going to use these three things and I'm going to substitute them into the Pythagorean theorem. So A is BC squared, right? Plus B, which is AC squared. And that's equal to C squared, which is AB squared. So on your homework, you might have some problems like this where they label the sides using the two angles that they're in between rather than using side lengths, right? So just saying lowercase a or something like that. Okay, so let's go through some examples here. So my first example says, for right triangle ABC with the right angle at C, if AC is equal to 5 and BC is equal to 12, find AB. So it says draw a picture and then label when needed. So I'm going to draw a picture here. We have a right triangle. That was bad. Maybe you want a longer right triangle, right? We kind of had a shorter side, hypotenuse, and a longer side. Okay, so this is my right angle down here. So I'm going to say that's angle C. And maybe I'll just keep it just like we had up here, right? So maybe I'll say, or maybe I'll switch it. Maybe I'll say A is going to be up there this time, right? Because I know that AC only has a distance of 5, right? So that would make it the shorter of the two sides. And then BC has a length of 12, right? 5 and 12. So the question is to find AB, right? So we're just trying to find the length of the hypotenuse. So if I want to do that, we just use our formula, right? Our Pythagorean theorem. So I'll use that. So we know that BC is equal to 12, right? So 12 squared plus 5 squared is equal to AB squared, right? So that's just from our Pythagorean theorem. And then we can start solving this, right? So 12 squared is 144. 5 squared is 25. And then AB squared is still just AB squared, right? So AB squared. Okay. So on the left side, that equals 169 is equal to AB squared. We'll take the square root on both sides. So we get 13 is equal to AB. So the square root of 169 is 13. And this time we only have to take the positive case because we're looking at distances, right? So we can only have a positive distance. So my hypotenuse is 13, or we can say AB is 13, right? Okay. All right, so that's pretty easy, right? So we're just using the formula and seeing how we can solve for the missing side, right? So let's do a few more examples. So this one says, a pole is on level ground and perpendicular to the ground. So we have guy wires, which brace the pole on either side, are attached to the top of the pole. So each guy wire is 25 feet long, and the pole is 20 feet high. So it says, how far are the grounded ends of the guide wires from each other? So draw a picture to help you solve. So there's a few spelling mistakes in there, but let's draw a picture first. Right, so we have this pole that's 20 feet high. Right, so we have a pole that's 20 feet high, and then we have wires coming down this way and this way, right, that are both 25 feet long. Right, and then it says the pole is perpendicular to the ground, right? So maybe I can draw this maybe just a little bit better, but we should have a perpendicular line down here, right? We have a perpendicular line, and this is 25 as well. Right, so we have this perpendicular line, they're both 25. And then it says, how far are the grounded ends of the guide wire? So how far is this point right here from this point over here, right? And notice that what we have is we have two completely identical triangles, right? We have a triangle here on the left and a triangle here on the right. And the reason I know that they're the same is because they have two side lengths that are the exact same, right? They're exactly the same thing on either side. So the question is, what is this length from here to here, right? So what is that length right here? So what I want to do is maybe I just want to find the length of half of that, right? So maybe we'll label this side X, right? So I want to find half of that. And then after I do that, I can just multiply it by 2 to find out how far they are from each other, right? So to solve for this, we can use the Pythagorean theorem, right? Because this is a right triangle. And we have one leg that we're trying to solve for. But we know what the hypotenuse is, and we know what one of the sides is, right? So let's plug that into the formula. So I'm going to say, well, we have x squared as one of our legs, plus we have 20 squared is the other leg, right, is going to equal 25 squared, which is the length of our hypotenuse. And we know it's the hypotenuse because it's the longest side, right? Okay, so now that we've done that, the next thing that we can do is start simplifying this, right? So to simplify this, I'm going to square those numbers. So if I do that, we get what? 20 times 20, we get what? 400. So we get x squared. And I'm going to subtract that 400 on both sides, right? Because I want to start getting x by itself. And then I'm also going to do 25 squared. So we get 625 minus 400, right, is equal to x squared. If I subtract, we get x squared is equal to what, 225? And then I can take the square root on both sides. And notice that we just need to worry about the positive case because we're worried about distances. So notice that x is equal to 15. Okay, so we know that x is equal to 15, but that's not the question, right? It says how far are the grounded ends of the guide wires from each other. So we know what half of it is, right? So x is just half of it. So we just have to multiply this by 2. We get 2x is equal to 30, right? And that's what our answer is 30 feet, right? 30 feet. Okay. Okay, let's try another example. So on the next one, this one says a jet travels 7.5 kilometers while gaining altitude at a constant rate. If it travels between horizontal 5.8 kilometers apart, what's its gain in altitude? So what this is saying is that we have some jet, right? And I'm pretty bad at drawing jets, so maybe, I don't know, something like that. Right? So we have this jet, right? And it's going up in altitude. And that's 7.5 kilometers, right? And we know that the horizontal amount that it rose was 5.8 kilometers. So the question is, what is our vertical length, right? So how far did we go vertically? Or sorry, if it travels horizontal. Sorry, so this is wrong, right? So that's switched. So we should say that 5.8 kilometers, right? Because that's our horizontal, that's our straight left and right. We want to know what is our gain in altitude, right? Our gain in altitude or our vertical, or right? What is our vertical x here? So I'm going to label that side x because I don't know what it is yet. But that's what we need to solve for, right? So simple enough to solve for, we just use the Pythagorean theorem again, right? Because we have this right angle here. So I should say that our hypotenuse, so 7.5 squared, is equal to 5.8 squared plus x squared, right? So if I want to solve for x here, so we'll just have x here. We have, that's the square root, because I'm going to take the square root on both sides, right? 7.5 squared minus 5.8 squared. Right, so I'm kind of omitting a few steps, but all we're doing is subtracting the 5.8 squared on both sides and then square rooting both sides. So we get x is equal to, you can take the square root still, 7.5 squared is what? Should be 56.25 minus 5.8 squared, which is 33.64. If I subtract those, we get 22.61. Okay, if we take the square root of that, we can say that this is approximately, so about equal to, let's see, 4.75 kilometers. Okay, so we could have the negative. To think about, right? But notice that he said he's specifically gaining altitude, right? So we have to take the positive because it's gaining altitude, right? If it said that he was descending at a constant rate, then we would take the negative, right? Because we're going down. Okay. Okay, so we've taken care of that problem. We can move on to the next one. So the next one says, a surveyor wants to determine the distance between 2 points, but a large building is an obstruction, right? So he wants to know the distance between A and B, but we have this building in the way, right? So he can't measure a straight line. He can't just throw out like a measuring tape, right? Because the building's in the way. One thing that we can do, though, is we can find a third point that's at a right angle from B, right? So we can do this. We can say, hey, let's go out 103 meters, right? And then we can kind of go up all the way up to B, right? And this is a right angle. So we can use the Pythagorean theorem here to find the length between A and B, right? So we don't know what that is yet, but we can find it out pretty easily. So the question asks to find the distance between A and B, and we can do that by solving for the hypotenuse, right? So we know that AB squared, right, is equal to the square of the two legs. So 103 squared plus 192 squared. Okay. So on the right side, we get what, 103 squared. Oops, 103 squared is equal to 106.09 plus 192 squared. So 36,864. Right? Add those together, and we get 47,473. Right? Then we can take the square root on both sides. So if we take the square root on both sides, we get about 217.88. And maybe I should write the approximately symbol for that, right? So it's not equal to that, but I rounded. It's approximately equal. And that answer makes sense, right? Since it's the hypotenuse, it should be the longest out of all three sides. And it clearly is, right? It's greater than 192, and it's also greater than 103. Okay. Any questions on any of the Pythagorean theorem stuff? So anything from this section? Okay. Okay. So we will move on then. So we'll do 13.5. So originally on the syllabus, it was for next week, but I think that I am going to do this section today. And then we'll just have two things to cover on Thursday. And if everything goes well on Thursday, assuming we get through both the sections, that'll be it as far as new sections that we'll cover, I believe. But instead, I'll do a review on Tuesday, an optional review, just to help get you ready for the final. So, and then not this Thursday, but the Thursday after, it's Thanksgiving, so we'll have that day off. Okay, so 13.5. So we're going to talk about trigonometry now. So many problems involve the use of triangles, right? So what we've seen before, altitude, or finding the length between obstructions and stuff. So in many problems, we're going to use triangles, right? Especially right triangles, Because of this, we use a new branch of mathematics called trigonometry. So it's really useful to find lengths without necessarily knowing what the lengths are, maybe one or two of the other sides. But anyway, so we know that a triangle is composed of 3 sides and 3 angles. So if we know one side and 2 parts of the other triangle, so maybe it's 2 angles, maybe it's the other 2 sides, or maybe it's an angle and a side. But as long as we know those 3 things, we can find the other 3 parts of a triangle. Okay. So what this is called, or what this is known as, is just solving a triangle. So if you have 3, then you can just solve the triangle, right? Yeah, so I think to answer your question really quick, so we did have class last Thursday. It was just pretty short. It was only about a half an hour. That was just finishing up some of the examples and stuff. I believe that I posted, not the last announcement, but maybe 2 announcements ago. I posted a YouTube video, I believe, of that. And then I also posted the annotated notes to it as well. So I would check the announcements. I think it was 2 announcements ago. Okay. Okay, so back to this. So this is known as solving a triangle, right? So when we're solving a triangle, we can use these things called trigonometric ratios. Use these things called trigonometric ratios. So I'll define them explicitly here, at least the first 3, and then we will find out what the last 3 are together. So let's say that I have a right triangle, so just like the Pythagorean theorem, right? So I start with a right triangle. If I want to find the sine of an angle A, right? So let's say I have this angle A here, right? If I want to find the sine of that, so I want to find the sine of angle A, we write it as sin of A, so just sine of A. And what that is the side opposite of A, right? So that's lowercase a, divided by the hypotenuse of A, or the hypotenuse of the triangle, rather, which is C, right? So in letters, that means A over C. As a mnemonic device, we can say that sine is SOH, S-O-H, right? So sine is just the opposite over the hypotenuse. So if I want to find the cosine of angle A, that is the side adjacent to A. And notice we have 2 adjacent sides, right? We have C and B, but C is the hypotenuse, right? So we only take the one that's adjacent to A that's not the hypotenuse. So in this case, it's B, right? So in this case, it's B. And then that's divided by the hypotenuse, which is C. Okay. All right, so that's just B over C, right? Side B over side C. And if we want to have a mnemonic device for that, it's ka. So we have so ka. And then if we want to find the tangent of angle A, well, that's just the side opposite of A, which is lowercase a, right? Divided by the side adjacent to A, which is B, right? So my mnemonic device here is TOA. So I know back when I was in school, or back when I was in high school or middle school or something, when I was learning about this, we had this mnemonic device, and it was SOHCAHTOA, TOA, right? So SOHCAHTOA, TOA, and that just reminds you on how to find the sine, the cosine, and the tangent of a triangle, right? So we want to find the other 3 formulas that we're missing. So the other 3 formulas, we have the cosecant, the secant, and the cotangent. And all that is just the reciprocal of sine, cosine, and tangent, right? So they're not anything different than the 3 that we just learned. They're just the reciprocals of it, right? So I want to derive the formulas here for these. So if I have the cosecant of angle A, so we're still dealing with A, but this generalizes to B and C as well. So this is how you write it in math, is the cosecant of A. And all the cosecant of A is just 1 over A, right? So this is just 1 divided by, and the sine of A is just A over C, right? Just A over C, because we already know that from up here, right? So we can also write this as 1 divided by a over c, right? And whenever we're dividing by a fraction, that's the same thing as flipping and multiplying it, right? So this is the same thing as 1 times c over a, or just c over a. So whenever we want the reciprocal of sine, cosine, or tangent, all we need to do is just flip the two sides, right? So the cosine of a is 1 over b over c, right? Which is equal to c over b. Okay. And then finally, the tangent, or the cotangent of angle A, is just equal to 1 over a over b, right? Which is just equal to b over a. Which is just equal to b over a. Okay. So that's how we find the formulas for these three, right? So they're just based on our original three, the sine, the cosine, and the tangent. So as long as you know what sine, cosine, and tangent are, you shouldn't have any problems finding the other three, right? You shouldn't have any problems finding the other three. Okay. All right, so we'll go through some examples here. So this one says, find the trigonometric ratio of a triangle with sides 15 and 12, right? So we're going to have a triangle here, right? So we have a triangle. And we know that the sides are 5 and 12. Okay. And I think from our previous, let me go back up really quick, just to kind of give you some time to write. I think from our previous one, we know what that is, right? Yeah, so we know that we have a side length of 13, right? No, we have a side length of 13 already. So instead of having to solve for this with the Pythagorean theorem, I'm just going to substitute that 13 in, because we already know the answer from last section. So if I want to find the sine of A, and maybe we'll let this smaller angle equal A, right? So maybe we'll let that. So I want to find the sine of A. That's equal to the opposite over the hypotenuse, right? So maybe I'll just write O over H. So opposite over hypotenuse, which is equal to 5 over 13, right? If I want to find the cosine of A, that's equal to the adjacent over the hypotenuse, right? So my adjacent side is 12 over here, and then my hypotenuse is still 13, right? If I want to find the tangent of A, that's what? Opposite over adjacent. So TOA, opposite over adjacent. And the opposite side is 5 over the adjacent side, which is 12. Okay. Okay. And then finally, if I want to find the other three, right? If I want to find cosecant, secant, and cotangent, if I want to find cosecant of A, well, that's just 1 over sine of A, right? Or we just take the reciprocal of sine. So we just take the reciprocal, which is 13 over 5, right? So we're just reversing the order of sine, right? Okay. If I want to find the secant of A, that's equal to 1 over the cosine of A, right? Or 13 over 12. Okay. And then if I want to find the cotangent of A, we want to take the 1 over tangent of A, right? So 1 over the tangent of A, which is equal to 12 over 5. Okay. Okay. The next example says, find the missing side of a right triangle where the tangent of A is equal to 3 over 4. And then it says draw a picture, right? So let's draw a picture here. So I'm going to draw a picture. We know it's a right triangle, right? That's the only thing we know. I remember that angle C is the biggest angle, right? Or the one across from the hypotenuse. Maybe we'll label angle A up here again. And then we'll label angle B over here. So we know that angle A, is what we're going to be focused on, right? Because we have the tangent of A equals 3 over 4. remember that the tangent of A is equal to the opposite over the hypotenuse, or sorry, opposite over adjacent, right? Opposite over adjacent. And notice that we know that it's 3 over 4, right? Notice that the tangent of A is 3 over 4. So we can say, well, the opposite side of A is going to be 3, right? Just by inspection. We know that the numerators are going to have to match. So O is going to be 3. So the opposite's 3. And we know that the adjacent has to be 4, right? So we know what it is just from the tangent that we're given, right? And notice that this isn't unique. The tangent of this isn't unique, right? Because we have 3 over 4, but 3 over the 4 is the same thing as 6 over 8, right? Or 9 over 12, right? So this is just one of the triangles that we could have, right? But maybe we could increase the size of this triangle if we wanted to, right? So we could increase the size and it would still be correct. But we'll just leave it as like this for now. And that's specifically why I said a right triangle, right? Because there's more than one here. Okay, anyway, I want to find the length of AB, and I can do that with the Pythagorean theorem, right? Because I know what the lengths of two legs are. So we should have 3 squared plus 4 squared is equal to c squared, right? Maybe I'll put a lowercase c, or maybe I'll even use the other notation. I'll say AB squared. So AB squared, right? So solving for this, we get 9 plus 16 is equal to AB squared. Okay. 9 plus 16 is 25, right? So, and I'll take the square root on both sides. So square root of AB squared. Right, so we get AB is equal to 5. Right, so the missing side is the length 5.